recording to start. Oh, I still need to get mine. All right, so good morning, everyone. Today is Thursday. We are on day 2 of 5.05. Day 3 would be tomorrow, so the quiz on 505 would be tomorrow, Friday. I want to let everyone know that I'm almost done with the lessons for this unit, and I looked ahead and looked at the exam. And so for your final exam in Unit 5, things are switched around a little bit. So, before you had like, what was it, like maybe like 15 questions on the test, and then you had like 3 TGAs, correct? That sound right about that? So, for whatever reason, for Unit 5, things are switched around. So, you're actually going to have like 3 multi-choice problems, and then you're going to have like 15 TGA like questions, free response on this unit. Lots of grading for me, so good thing it's the last unit, so I have plenty of time. So, yep, 15 free response, word problems, Unit 5. And then you have a 1 week period to get those turned in. So that's going to be a lot of fun. So, yep. Everyone's excited, right?
That's the part 1 for Unit 5.
So part 1 is multiple choice, 3 questions, and then it's switched. Part 1 is 15 free response questions. Part 2 is actually going to be 3 multiple choice.
What?
Yeah.
Okay.
Everyone's excited, right?
Are the first the 15 whatever are they still gonna be easy though?
Nope. Give me a nightmare. Whoever's freaking out. I'm just kidding. April Fools. Yes, today is April Fools. Panic attack can stop. Yeah, you forgot it was April Fools. I'm sorry, everyone. I couldn't resist. I'm sorry.
Well played.
Hashtag not sorry. All right. Some of you almost cried. Some of you did cry. I'm sorry. April Fools. Yeah. Nope.
And the Oscar goes to...
Thank you very much. Thank you. All right. Being recorded. All right. So graphing on a complex number. So we're used to the Cartesian coordinate plane. Well, to graph complex numbers, remember complex numbers are in the form a plus bi. If you were not here yesterday, hopefully you watched that recording so you know what I'm talking about. If you don't know what I'm talking about, well, you may want to leave this live session and catch up on the first lesson because you're going to be lost. So again, complex numbers in the form of a plus bi. To graph these, we use the Argand plane versus the Cartesian coordinate plane. Traditionally, you would have your x and then your y, but now the x is going to be the real number, a, and then the y, the vertical, well, that's going to be the imaginary, b, and that's it. All right, so let's graph. So a, so -5 plus 5i. So a is -5, so we go left 5 units for the real number. And then 5i is imaginary, so that's positive, so we go up 5 units, and then that's where you plot your point. So there's point A. Wait, so it's literally the same? The same as what? This seems too simple. Well, don't worry, Antonio. This gets harder. It always starts off a little easy, then we kind of just work into it. So, okay, so B, let's look at B. We have 3 is the real number, so we go to the right 3 units on the real number line. And then I is 4, so 4i, so we go up 4 units, and then we plot that point. And then that where B is at. Pretty simple. All right, C, we go right 3, then down 5. D, we go left 4, and then down 4. Okay. Where do we go for point E? How do we plot that? It's just up 4. Yep, just up 4 units. All right. What about point F? Where do we go? Just left 1. Yep. Oh, I forgot to show the point. All right. Any questions on graphing complex numbers? Pretty straightforward. Yep. All right. Modulus of a complex number. So, read this. The absolute value of a complex number, I underlined this for a reason, is the distance from the origin, so the very center of your graph, in the complex plane. The absolute value of the complex number is also known as the modulus. So you might hear me say, you might read in your modules, it might say the absolute value, it might say modulus. They mean the same thing. They are interchangeable. So again, the absolute value of a complex number versus the modulus of a complex number, they mean the same thing. So make sure that that's clear. All right, so because the complex numbers are considered a single number, so even though we can graph them on a 2D graph, it's a single number. So like it says it here, it's represented in 2D. You have your horizontal location, and you have your vertical location on the Argand plane on the previous page. So, remember, the complex number, it's a single number. So going back here just to stress it, -5 plus 5i, that is a single number. That is a complex number, okay? Even though there's 2 terms, that is a single number. So I keep saying it, but you need to understand that. All right. So the best way to visualize how big that number is, that complex number, we use the modulus. So the modulus is a way for our brains to easily understand how big that complex number is. Because looking at a plus bi and comparing, so at quick glance, comparing these 6 numbers, right? Comparing these 6 numbers at first glance, it's hard to wrap our brain around how big those numbers are in comparison to one another. And that's why we use the modulus. Everyone good so far? All right, all right. So the modulus, the formula for the modulus is, so let's say the complex number z is equal to a plus bi. So z is the complex number in this form. The modulus, also known as the absolute value of that complex number, is equal to the square root of a squared plus b squared. This is the formula. So whenever you see absolute value bars around like this variable, well, remember it is absolute value, but the absolute value is the same thing as the modulus. They mean the same thing. And if you do this calculation, you will get a single number. And that single number allows us to visualize how big that number is. What does this formula look like to you? Crickets, crickets, crickets. Yeah, it looks kind of like the radius, right? The Pythagorean theorem, the radius. Yeah, so A is the horizontal distance, right? B is the vertical distance. So let's go back to this previous page. I'm going to use green so it shows up. All right, so let's look at point C. All right, so we have the A value, which is from here to here, right? So that's your A value, and that's a distance of 3 units, correct? So let's put a 3 here. And then you have your B value. Your B value is negative, was it -5? Right, -5. Everyone agree so far? You got the A value, you got the B value. So yeah, so that's basically the radius. I'm gonna use, let's use, what color should I use next? I'll use blue. I'll use blue for the radius. So from the origin, is there an eraser? Can I use an eraser? Oh, I can use an eraser. Okay, I have to erase some of my line because I should have started at my origin. All right, does that look better? Starting at the origin? So then from the origin to that point here, that is the modulus of C. So the distance from the origin to that point is the modulus, which is basically the radius. Everyone see that? All right. So if you draw a line from the origin to all points, that distance, that single number, allows us to understand how big that number is. And that's much easier to look at and understand the bigness of it, the largeness of it, versus looking at the complex number form. You all agree with that? Okay. So let's look back. I thought I had a graph. Where'd my graph go? Oh, it's on this page. Oh, okay. I'm thinking ahead. Okay, so let's practice of actually calculating the modulus. All right, so we have -1 plus 6i. Everyone go ahead and find the modulus of number 7. I'm going to give you all 45 seconds to do that. Give me simplified radical form. And then also give me, like, I don't know, 2 decimal places for fun. Yeah, I don't know if your quiz. So sometimes your quiz asks for like simplified radical. Sometimes it asks for rounding to nearest hundredths or tenth or thousandths. You need to obviously read the question to ensure that you give the answer to what they're looking for. Yeah, so give me radical form, and if there is radical form, it might actually just become a single integer in 2 places. Yeah, give me both. All right, time's up. On chat, go ahead and type out what you got. Oops. Oh my gosh, it won't stop. Why won't you stop? Oh my gosh. Jeez. All right. So we got rad 37, which is about 5.92? Rad 37, 6.08. Yeah, so I think rad 37 rounded is 6.08. I believe that's correct. Probably mistyped. Yep. All right, so that should look like the square root of -1 squared. And again, make sure that negative is in parentheses. So if you didn't put that negative in parentheses, you would have had rad 35 because you would have had -1 plus 36 is rad 35. So you need to have parentheses around your negative numbers when you square them. It matters. So yes, you mistyped that. Don't give up yet. Don't give up. So yeah, rad 37 or about 6.08. All right, everyone, let's try number. Let's try number 8. Right, quick. Number 8. And then we'll jump down to numbers 11 and 11. We'll jump down to numbers 11 and 11. Thank you, Antonio.
You're welcome. If you started on 12 index examples, though, you're kind of on your own at that point.
I know. It's probably what I did because I'm good like that. Actually, I stopped using numbers after that point. So I'm safe. All right, number 8. What does y'all get? 5? Just 5. Yeah, 5 sounds good, I think. Yep, 5 looks good to me. Right. I'll come back to number 9, and I'll just show number 9 and 10. So if you're watching this recording, make sure you pause it and try these on your own. That's 9 should be that. Number 10 should be this. All right, number 11. Let's do 30 seconds for number 11. All right, what did everyone get for number 11? 3. 3. Looks good to me. Yeah. So remember, that's even though it's negative 3i, you can think of it as being 0 minus 3i. So it's in that complex number format, a plus bi, right? So it's 0 minus 3i, which means number 12 would be, well, negative 2 plus 0i, right? All right. What did everyone get for number 12? Dos? I think that's right. Yeah. So your modulus should always be positive. Everyone agree with that? Yeah, just the way the math works. Whenever you square a negative number, it becomes positive. So your modulus will always it'll be 0 or positive, right? Remember, 0 is neither positive nor negative. So it's possible, like, if your number is 0, what's the modulus of 0? Well, it's 0. So basically, your modulus is non-negative, right? Non-negative. All right, now we're getting to the good stuff. The meat of this lesson. The triangle inequality theorem. Now, should have learned this in geometry, but probably not to this depth. So in a triangle, you learned in geometry that when you have, let's say I have this side here, this side, and then I have this side here. So 3 sides, triangle, right? You learned in geometry that the sum, to be a triangle, the sum of any 2 sides, so let's say I do this side plus this side, the sum of those 2 sides will be greater than the 3rd side. So if I do this side plus this side, that length is greater than this side. If I did this side plus this side, that sum is greater than this side. So no matter what two sides you choose, that sum of those two sides will be greater than the third side, right? Sound familiar? Yeah. So going further with that theorem is this. So the modulus of P, remember, and these are complex numbers. So the modulus of P plus the modulus of Q must be greater than or equal to the modulus of P plus Q. So this, you don't write this down. You can use this on your test. So this, all this is saying is this distance plus this distance must be greater than the sum of those two distances. And here's something else I want to point out. So I am not going over it this unit. So there's some things I left out of my live sessions because it's an easy concept and you need to, those modules are required. So there's something called the head-tail method and the parallelogram method when you add vectors. Oop, actually, I'm thinking ahead. Sorry. I'm going to save that thought until later. Sorry. I'm thinking about vectors and we're not to vectors yet. So just kidding. Shh. I'm teaching ahead. My brain's all mess of this unit. All right. But anyway, ignoring what I just said. So, all right. So I just wrote these things. I'm stating obvious observations. So the modulus of P must be non-negative, and we talked about that. Your modulus is always positive or zero, right? So non-negative covers zero or positive. Modulus of Q, same thing. It's non-negative. You know, that's a given, right? The sum of the moduli, plural, right? Moduli, must be non-negative. Oh, I'm sorry. Let's see. The sum of the moduli of two complex numbers is greater than or equal to the modulus of their sums. Okay, we talked about that already in simpler words of the whole triangle theorem. And the modulus of the sum must be non-negative. So yeah, it's modulus is always non-negative. That's a super, obvious. That's why this is just stating obvious, right? This is my observations that I'm making that I'm telling you guys. All right. So something else I want to just kind of state about this graph here. So you have your P and then your Q. So the blue ones, the P and the Q, are the original complex numbers. This point here would be point Q, so complex number Q. This point right here, this would be complex number P. These, I think that's black. These black lines, all they did was they just basically copied this line and they dragged it, drug it. I don't know what's the right word. They dragged it. They dragged it through the mud all the way up here, and they had just attached it to the end of the blue point. And then for your point P, that distance, again, they just copied it and they just drug it over here and attached it to the end of point Q. And then wherever those lines met, which is right here, that is the sum of those 2 points. And we're going to talk more about that in the coming lessons, not this week though. All right, so using the theorem, these take a lot of work. There's a lot of work involved. So this one says complex numbers. So H and G are complex numbers. Well, that's good to know. So they're both complex numbers, and the modulus of H is equal to 3x plus 1, and the modulus of G is equal to 4 minus x. So you can visualize, remember, modulus is the distance from the origin to that point, right? And we don't know exactly how long that distance is. We're given an equation. So really, we can make x anything. And then that distance can really be anything, right? But there's constraints here. So the distance, so the modulus of h is this, modulus of g is this, and then it says, and the modulus of h plus g is equal to this. So there's basically three equations working together that there's only a set amount of x values that would make this true. So remember, in triangles, the sum of two sides must be greater than the third side, no matter what two sides you choose. And that's what this formula does and ensures that we don't break that rule. So with those restraints or constraints, we want to know what inequality expresses the possible values of x. So, what x values will make that true. So you're thinking, how do I approach this? Well, we use the formula. And remember my observations? What was one of my observations that I made about a modulus? Yeah, they're always positive or zero, right? So they're always non-negative, right? Yeah, so we're going to use that idea in this. A lot of blue boxes, right? So I have them labeled H, G, and then H plus G. So I'm just going in order here. So H, the modulus, this has to be greater than or equal to 0. So that's what we do first. H, that modulus must be greater than or equal to 0. Okay, so remember that's just an obvious observation. It has to be true. So I write that down. H is 3x plus 1. It must be equal to or greater than 0. G, again, that has to be greater than or equal to 0. So I write that one down too, just like that. And then H plus G, that modulus, again, it has to be greater than or equal to 0. So those are four things, or sorry, not four things. Those are three things that must be true. So you just write them down, and then you solve all three of those separately. All right. So I'm just going to kind of go through this. This is really simple math, very trivial. So subtract 1 both sides, divide both sides by 3, and then you have your answer. And then if just for fun, you can write it in decimal form, just to see what it looks like. And really, writing in decimal form is important in the end, and you're going to see why. Just because most people can't really think in fractions of like which numbers are bigger than another number, especially when fractions get kind of like big, right? The numerators and denominators, they're really big. 1/3 versus 1/2, I think that's pretty easy. 1/4 versus 1/2, 1/4 versus 1/3. Those are very simple ones that I would say a lot of people can do. So I just write the decimal just for the later steps. All right. G, solve that one. So, we're going to subtract 4 both sides. I don't know why I wrote it again. Whoops. All right. We are subtracting 4 both sides, and then we divide both sides by -1. Now, don't forget, when you divide an inequality by a negative or multiply by a negative, what can you never forget? Yeah, you have to flip. Yeah, you had to flip the inequality. So you divide by -1. Do not forget to flip the sign so it becomes x is less than or equal to 4. All right, everyone good so far? All right. So far this, understanding how to do this problem is much harder than the actual problem itself. So if you look at this problem without me showing you these steps, you'd be like, I have no idea how to even approach this. So knowing the approach is the hardest part about these. The math is super easy. All right, so I'm going to jump over to the H plus G. So we solve for that one, and subtract 1, divide by 4, and just convert to decimal just so we can see it, because we're going to use that in our very, very last step. All right, now the middle one. So there's a reason why that's between those two, and I really can't think of why I did that. I just did. That's just where I put it. So you have to put it all together, right? We have to put this all together. Modulus of AH plus modulus of G is greater than or equal to the modulus of H plus G. We just write the theorem itself. And we're going to plug in all those little parts that we found. So the modulus of H we found, oops, moving the wrong box. The modulus, why isn't my box moving? Hold on, I'm having moving issues.
Want me to move it? I can move it.
No, don't move it.
Okay.
Okay, now it's working. Hold on, let me just go back and then forward. New row is having these new features being added apparently every moment. I'm just going to delete it. I can't move it. It's not working. All right. Let me just use my pointer then. All right. So H we know is 3x plus 1. So I just copy H here, right? Because that's what it equals, right? Modulus of H is equal to 3x plus 1. So I copy that here. Modulus of G, that's 4 minus x. So I replace that with, well, what it equals to, right? Copy this down. And then modulus of H plus G is 4x plus 1. So I just replace that with this. And now we just solve that. So combine like terms. I'm just going to show it real quick. So on the left side, we have 3x plus 5. Oh, sorry. 3x minus x is 2x. And then 1 plus 4 is 5. And then what did I do? We do a couple things. Okay, so I kept my x on the left-hand side, the equal sign. And I would say it's probably easier if everyone does that, because most people, they don't read inequalities correctly when it's on the right-hand side. And maybe another date, I will kind of maybe go over that. But people don't read them correctly when it's switched around. But anyway, so try to keep x on the left-hand side of the equal sign, or on the greater than or equal, the inequality sign. Makes things easier in the end. All right, so subtract 4x both sides, and then also subtract 5 both sides. And now we're going to divide both sides by -2, and don't forget to flip the sign. So now we have x is less than or equal to 2. All right, so those 4 pieces, everyone follow of, well, why I did that and the answers I got, because...
Can I ask one question?
Yeah, sure.
Just to clarify, here the sign did not switch because you did 2 subtracting, correct? So it cancels each other out.
So remember, you only flip the sign if you divide or multiply by a negative. You're allowed to subtract or add negative numbers. It doesn't do anything to the sign.
Okay.
Yeah. Good question. All right. So everyone's good on these 4 little pieces, right? All right. All right. So now the hard part. It's not really even that hard. All right. So this blue, I wrote that as a note. So out of those 4 restrictions, we have to create an interval with the most constraining requirements. All right. So let me do a number line here. I wish I had more room. Need to align. Everyone likes pictures, right? I like pictures. All right, let me do a line here. So here's my line. And let's do, all right, so we got to plot some points on this number line. All right, so we're going to plot all 4 of those points on the number line here. We have, so we got a point at 4. So here's 4, right? So here's 4. And then x must be less than or equal to that point. So I'm just going to do like a 4, it has to be less than or equal to that, right? So I just, arrow pointing to the left. That makes sense, I guess. And then, okay, let's plot point 2. So I'm just going to put, here's 2 right here. And this one says that x is less than or equal to 2. So, it has to be less than that. So out of those 2 points, if x must be less than or equal to 4 and then x must be less than or equal to 2, which one's more constraining? Yeah, so the 2 is more constraining, right? So if your value of x must be less than 4 and less than 2, well, 2 is more constraining. Because if I chose 3 for x, well, 3 is less than 4, but 3 is not less than 2. So 3 is not valid. So the most constraining out of these 2 points right now, the most constraining would be that 2. Right? So, all right, let's keep going, plotting more points. All right, we have x is greater than or equal to negative 0.3, and x is less than negative 0.25. Now, this is why I converted my fractions to decimal, so I could, more easily plot those points. And that's really the only reason. So I'm going to put right here, this would be negative 0.25. And then over here, I'll put negative 0.3. And obviously, this number line is not to scale at all, but I want to have enough spacing to write my stuff. All right, so going back to, so let's start at negative 0.3. This one says x is greater than negative 0.3. So greater than is to the right. So I'm just going to do an arrow pointing to the right. I'm running out of room, so I'm just right above it. And then going to negative 0.25, that one says x must be greater than or equal to that value. Well, okay, so that's also telling me that must be bigger than that number. So that's to the right too. All right. So looking at those 2, and I'll put the arrows here above, right? So looking at negative 0.3 and negative 0.25, and that x must be greater than or equal to both of those, which one is more constraining? The negative 0.25, yes. And you can think of it this way: if I chose a number between those 2 points, let's say like negative 0.3, not 0.3, negative 0.29 or 0.28, sure, yeah, negative 0.28 is bigger than negative 0.3, but it's not bigger than negative 0.25. So just think of some random number between 2 points and then ask yourself, am I bigger than both of those in this case? And the answer is no, you have to be bigger than both of them. So this is the most constraining for the greater thans, and this one is the most constraining for the less thans. So it's these are the most constraining. So that tells us that x must be greater than or equal to negative 0.25, and x must be less than or equal to 2. And that's what we're going to write down. So again, x is greater than or equal to negative 0.25, and x is less than or equal to 2. That's what we figured out over here. And then let's write that into interval notation. And that looks like this. X is from negative 1/4 to 2. Brackets because, well, they're solid points. Solid points are the greater than or equal to or less than equal to symbols. So those are inequality format and interval notation. I don't recall what your test or quiz wants. You should know how to do both. I think it uses interval notation, though.
Really quick, what is like the like I guess definition of the most constraining requirements? Because I think I'm like most confused on what exactly.
Ooh, oh man, I don't. English not so good for me. Most constraining. So, let me think of like a good example that's not like math related. Most constraining. So, um, let's see. You go on a roller coaster, and the people in charge. One person says that you must be more than 80 pounds to ride this ride. But then somebody runs data and says, oh no, you must be more than 100 pounds to ride this ride. Um, which one's more constraining, 80 pounds or 100 pounds? And well, the answer is 100 pounds. 80 pounds doesn't meet the other requirement. So you can think of it this way about most constraining. If you're comparing now, you're only comparing ones that are like, see, this is greater than, and this one's greater than. So you're only comparing these two to each other, and these are less than. So you're only comparing these to each other. These are less than, and these other two are greater than. So looking at the greater or the less thans first. X is less than 4, and X less than equal to 2. If you're not sure which one's more constraining, just plug the number into the other one. So if I take this 4 and I take this 4 and I plug it into here and I say, hey, is 4 less than or equal to 2? Well, the answer is no. And the reason why is because this one is more constraining. So we could cross this out. Now, if you did the other way, if you plug this 2 into this X and you said, hey, is 2 less than or equal to 4? The answer is yes. Yes, it is. So it works. But again, plugging this into this, it doesn't work. So we can actually just cross that off. If you go over here and you plug in negative 0.25 into this X, you say, hey, is negative 0.25 greater than or equal to this? The answer is yes. So that would be the answer. Now, vice versa, if you chose this to plug into this one, you would say, well, is negative 0.3 greater than or equal to negative 0.25? The answer is no. So we would cross that off. So that's another approach you can do rather than draw this number line. Hopefully that helps. And I don't think I have any other way to explain that. All right. So the hard part comes down to, even though it looks like a lot of work, the hard part actually comes down to, well, getting your data and figuring out the most constraining intervals to see, what actually works. So, all right, let's try this one. This one says, suppose V and W are complex numbers where modulus of V is 3 rad 2 and modulus of V plus W is equal to 7 rad 2. On what interval must W fall on? Now, if you see a problem that doesn't have any variables, be extremely happy because they are extremely easy. Like probably 55 times easier. Well, we're still going to use the theorem. And we are going to, well, just rewrite it in that form. Modulus of V plus modulus of W is greater than or equal to the modulus of V plus W. And then all you're going to do is just plug in the stuff it gives you. Modulus of V is 3 rad 2. Modulus of W, we don't know yet. That's what we're trying to figure out. And then modulus of V plus W is 7 rad 2. So you just, you plug in the stuff. And it's beautiful because there's no variables other than obviously W. Right? Then we solve. So subtract 3 rad 2 both sides. And that's it. We're done. Yep. So on what interval must modulus of W fall on? Well, modulus of W must be greater than or equal to 4 rad 2. Interval notation would be from 4 rad 2 to infinity, right? Because that's what interval notation is, the lowest number to the highest number. And for the highest number, sky is the limit. So that's it for that one. It's always easy when there's no variables. It's the variables that make it just a pain. I have 2 more pages, but if you have to go, let me go ahead and just paste the link right now. Because I basically have one example of both of them. So you won't have time to kind of hang around for any of them, I think. But go ahead and paste this now for people that need to go to their next class. If you want to watch the rest of the recording after, knock yourself out. But it's just 2 more examples of what we just did. All right. All right, page 9 of 10. All right, everyone try this example. I'll give you all, let's say, 2 minutes to solve this. Probably take you less than 2 minutes. Ready to go. All right, give me the interval notation in chat, please, for this answer. Interval notation. -3 rad 5 plus 7 rad 2, comma, infinity. Ooh. I like that. I like Emily's answer. I don't like Antonio's. Decimals, barf. 7 rad 2 minus 3 rad 5. I would also take that answer too. Yep. Yeah, so I looked about, which one you should write first, the term with rad 2 or the term with rad 5. And, I couldn't really find a definitive answer. I always thought to put the one with the bigger radicand first. So like the -3 rad 5 would go first, then plus 7 rad 2. But, I don't know if that is true. So either way works. But yeah, that is the answer. 7. Oh, and actually, I didn't write that way. I wrote it this way: 7 rad 2 minus 3 rad 5, comma infinity. I didn't tell you if I want it in simplified radical form, which is what that is. So, Antonio, you're probably right too, if that's what the rounded answer is. But yeah. So yeah, these are obviously a lot easier than the first example we did. Any questions on this type of problem? Yeah, so I remember looking through the modules of this section, and I thought it was super confusing the way they presented how to approach these problems. So I try to clean it up a little bit. But the important part is you do the examples in the modules and see if your answer matches their answer. That is what's important. Don't just skip those examples. Again, I can check anybody's access to those modules, see how much time you spent into each section, which is kind of a pain, so I don't always do it unless you're not doing so good. I do know all sometimes. Isn't clairvoyant? Isn't that the right word? Omnipresent, clairvoyant. I know all sometimes. All right. So here's the long one. I'll just uncover that to see how much work you have to do. So just to kind of give you a little like shell, you want to work, the inequalities out, m and then n, and then m plus n, and don't forget that middle one, or almost, right middle, the upper middle child, right? If there's 4 kids, do that one too. So this one's going to take a while. Whew. Let's do this. I'm going to give all of you 3 minutes to see how far you are. I really feel 3 minutes is probably definitely not enough, but it might get you really close. So 3 minutes, I'll check back and see how everyone's doing, and then give you more time as needed. So 3 minutes. And again, if you have to go to your next class, the link is in the chat. So come back and watch the video later if you would like. Omnipresent means you are always there. I don't think that's a true statement. I'm not waiting for you to mess up. I'm waiting for everyone to learn from their happy accidents. Just call me Bob Ross. We're gonna create happy intervals and happy inequalities. All right. So let's do this. If you are done with the inequality, this work for M and N, give me a green check if you're done with those first two. With those first two. I mean, X if you're not done with those first two. And then I will just assume everyone else is just, you know, maybe you have two new row sessions open and you're in your other class and you just want to see the answer. You know, that's what I would do if I was one of you. Oh, all right. So most of you are done with those first two. So let me just show the work for those two. All right. Let's do 3 minutes for the other two columns. So get those done. I think it should be more than enough time. The audio overlap is insufferable. Shall I whisper? All right, guys, you all have 3 minutes. There's 2 minutes, 34 seconds left. ASMR, yeah. Should I crinkle some paper up too? Unless I crumple the unit circle. Time's up. All right, let me just show the work for those two. Should be rather simple, I think. Everyone get 1/4 for that one. You need one more minute. Is that Emily? Is that 1 minute to finish the entire problem? Like the last, meaning the second, the one that I haven't uncovered yet? Okay. It's all right. Julie, I'll see you next time. Tomorrow, that is. All right, we'll do 1 more minute for that last column for Emily. All right. The last column. What did all of you get for that last column? What's the inequality? Anybody have it? X is less than or equal to -13. Negative.
Negative 13 over 15.
Okay, -13 over 15.
Positive, I mean, positive. Yeah, less than. X is less than or equal to 13 over 15. I cannot speak today.
Okay. Okay. Yep, it is positive. I agree. And again, converting those to decimal will help you when figuring out the restraints. I'm going to do it the whole like plug into the other one method to see, which one's most constraining. So again, you're only comparing the ones that are greater than to ones that are greater than, ones that are less than to ones that are less than. So we'll do the middle one first. All right. So let's look at this column and this columns because they're both less than or equal to, less than or equal to. That's a greater than and that's a greater than. So we'll do those last. All right. So all we're going to do is I'm going to take this one. I'm going to plug it into X here. And then we ask ourselves, is 0.67, is that less than or equal to 0.87? Is that true? It is true. Because it's true, that means that that is the most constraining inequality. So I'm going to circle it, and then I'm going to cross this one out because that one is less constraining. And I can vice versa. I can plug the other one in. We can say plug this into X here, and we ask ourselves is 0.87, is that less than or equal to 0.67? Is that number, when plugged into here, is that less than this number? Well, what's the answer? Is it yes or no? Yeah, it's not. So that one is a fail because it is not, that means that is not the most constraining inequality. So maybe doing it this way I know it's faster than graphing all of them. Would you agree? Yeah, and maybe for some of you it makes more sense doing it this way. Um, I like it. I like doing it this way. I think it is faster and easier. All right, now let's look at the other ones. So greater than or equal to, greater than or equal to. All right, so let's plug this one into this one and check. So -2. Is -2 greater than or equal to 0.25? Is it? It is not. It is not. So that's a big fail. I'm just going to cross it off, right? And which means if that one fails, this one has to pass. So I'm going to go ahead and just for fun, just check it just to make sure. One should be true. One should be true. One should be false, right? If you get like 2 false, it means you thought of it wrong, or I don't know, you wrote something. I don't know. One will be false, one will be true. It has to be that way. All right, so we're going to plug 0.25 into x here, and we say, hey, is 0.25, is that greater than or equal to a negative number? Well, the answer is yes. So that's why this is true. This one is the most constraining. So we're going to use that one. All right, and then we write our inequality. So everyone in chat, go ahead and write down the interval notation of your constraints. One-fourth, 2/3, brackets around both. I would agree with you. I would agree with you. Yep. 1/4, comma 2/3, brackets around it. Here is the interval notation, if you're wondering, you wanted to see it. Some people like to do this first before converting it to interval. Me personally, I just like going straight to interval notation. But again, I don't know. I can't remember if your quiz or test or modules want one or the other. I don't remember. So I'm giving both. All right. So hopefully, these like a lot of things in pre-calc, they take effort and they take practice and time spent maybe watching this recording again and pausing the parts that you need. Definitely going through the module examples and the practice modules to work those out, so you can, the more you do, the easier it becomes. So don't be discouraged if you find this very difficult at first. It probably should feel that way, but you practice enough, it becomes pretty easy. So all right. Well, guys, thanks for hanging around, and as always, I hope you learned something, and I will see you all tomorrow.